Good afternoon, all. Thank you for joining our today's webinar on help ensure the best designs with component management. I'm Sairam, working as team lead ADF for Altium products here at GSAS Microsystems. And today's webinar is under recording. If anyone is having any questions during the presentation or during the demonstration, please type your questions in the chat. We'll discuss at the end of the our session. Now, let us get started. Here is the agenda. The first two sections, I'm going to review about the electronic components in Altium Designer and the aspects that constitute the most optimal component. And I'll follow this with a discussion on approaches to creating and storing components. And we'll touch upon components lifecycle considerations. Next, I will review Altium libraries, Migrator capabilities, which allow legacy Altium file-based and database libraries to be migrated into an Altium 3-step workspace. Then I will provide a demonstration and we will end the session with the Q&A. So, what is an electronic component? It depends on where the design is in design process. Once a component is placed in schematic, it a variety of aspects that are critical to an entire design cycle. In the schematic stage, the component is represented as a symbol that has a set of pins and that are connected to other schematic symbols to represent the circuit design. In addition, the component having parameters such as value, accuracy, package type, and etc. During simulation, the corresponding models will be used to model the behavior of the component for the detailed analysis. Once the components are forwarded to physical design, they will be represented as a PCB footprints. The footprint may also contain additional graphics in mechanical layers, a 3D visual aspect, and more. Throughout all design stages, an important aspect of the component is its availability and the cost. Part procurement can occur anytime after completion and approval of the schematic design and move in parallel with board design. For procurement, the name of the component and the manufacturer are important. Also, you need to know which supplier sells them, what their cost is, whether they have them in stock, and whether they are still in production or not. The component impacts many aspects of the design. Let's review the approach used in Altium Designer to represent a component at different stages of the design process. In the first case, using separate schematic symbol and PCB footprint libraries, the symbol is fundamental item and component parameters. PCB footprints, simulation models, and data sheets are associated with the symbol. The next generation approach used in RT55 utilizes a separate component entity. You can think of as a container of sorts for all aspects of electronic components, symbols, footprints, 3D aspects, etc. All items have been discussed. In addition, all of these component aspects are stored in a workspace foundation and have their own unique life cycles and revision history. For example, the schematic symbol can be applied to other similar components and cloned. Also, a component can be linked to a variety of part choices available from variety of part vendors. Now, let us talk about the optimal component should contain. The component composition depends on the requirements of the particular company, but most often it contains the following set: a schematic symbol, representation used in creating schematics and connection between components, a set of parameters. Parameters can be used to display values on the schematics to search for components in the library. Also, they can be used to generate a list such as bill of material. A component also convey a footprint that represents the component physical attributes on a PCB. In addition to pads, the footprints can contain additional graphics and mechanical layer. For example, to show the outline of a component or a courtyard which can be used in layout, ideally a 3D model is associated with the footprint to reflect the physical size so that we can control the required clearances between components on the board and can generate a complete 3D visualization of the board. It's important to include links in component that point to datasheets and other supplementary information such as PDFs for the components so that designers can quickly access the documentation when needed. If we are working with Altium 365 library, components have life cycles and revisions. Also, alternate path choice may be specified for a component, such as capacitor of the same value but from different manufacturers. What happened in practice? Do all components have similar composition? Quite often. Designers encounter the following situations when creating a symbol. The parameter data is not complete. For example, a register or capacitor symbol is used and the parameters are already completed in the schematic, but not with the proper values. Also, when pursuing rapid creation of schematic, designers may not associate footprints to symbols as they only need to create schematic for a deadline. Incorrect footprints can be associated with components already in the schematic, leading to potential errors. Most often, these result in a polarity mismatch between the symbol and footprint, or the wrong footprint has been defined and the problem is detected. Late cycle at the assembly stage. Another common situation is that the designer uses a component from library which has often been used before, but in fact the part is not recommended by the manufacturer for new designs. That is all. In the near future, its production will stop and it will be unavailable. Also, another common mistake is the name of the component, such as the IC missing the suffix code indicating the package type. From the point of view of the circuit designer, there is no difference in the symbol, but from the perspective of PCB designing and purchasing, the suffix define the package type is critical. Fortunately, the procurement department will typically ask which one to buy, but sometimes they don't inquire. This is just some of the possible errors due to incomplete components. And if your component library is not accurate and complete, you will risk errors and wasting your time in every project. The reason for incomplete component libraries can vary and is often rooted in supplier approaches to creation and storage of the libraries. Let us consider some approaches to create the components. The first approach often used in many companies is to create a standard that defines the composition and rules for creation of both symbol and footprints, and everyone is required to adhere to these rules. The approach is good, but is not eliminate the issues due to common errors. And it is very useful to determine who can add new components to library. When anyone has rights to create a component, the outcome has been less than outcome. A more advanced option used in large companies is assignment of designated person to the role of librarian. In this case, it's important to understand how requests will be delivered to the librarian and what type of information should be accompanied and each request. You need to understand how the person should send requests for the new component creation. Will it be a letter, memo, email, etc. And also, the librarian can make mistakes. Therefore, it is useful to have component checked by another person or system. While they offer a considerable improvements, these approaches still do not guarantee 100% correctness of created components. Ideally, you need a system that supports a standardized components creation processes with the ability to limit staff access to add components. This system should also include the capabilities for requesting new components together with automated validation of components against various criteria. The definition of life cycle are also useful for assuring incomplete or unvalidated components are not invalidly deployed to designers. This capability for organizing components libraries is already available in Ultimate 365. You can create components templates for standardization for say register, capacitor, diodes, ICs, etc. The templates can specify which symbol and footprint to automatically associate to the created component. Also, a set of parameters that must be completed can be specified in template. The creator will not be able to save the component without entering the data for all parameters as defined by the template. This ensures this vital data is consistent across your organization component libraries. In addition, the system has ability to manage rights as well as the function for requesting new components, including pull request to be designated team member. When you create a new component using a template, the symbol and footprint will be associated immediately. Also, there will be a set of parameters, but they will not be completed. To complete them, you must enter the full name of the component if it is found in database of suppliers. The component creator will be offered the option of automatically populating the parameters such as value, working voltage, package types, etc. When you save the component to the library, the component is put through the mandatory checks such as missing parameters, approved, symbols, and footprints, etc. Such a centralized component library system with proper configuration will eliminate most of the errors that can be made when using conventional approaches to library creation and management. Now, let us talk about the library storage. Libraries can be stored locally, especially when the design department is small. Everyone works with their own libraries, periodically asking a colleague if they have such a component. They can also share the libraries or periodically merge libraries with each other into a one common file. This is less than a optimum approach for the enterprise. If one staff member gets sick or leaves, there may be a problem accessing to the library that the person had maintained more than uh, several libraries are used. Specific who can add a component by assigning the roles. In terms of organization, libraries of symbols and footprints are often divided into component types. Registers, ICs, diodes, integrated libraries can be provided to users. However, the main disadvantage is redundancy. For example, when users create capacitor of different values and they actually have the same symbol, another example is an SOT23 package. It can be accommodate diodes, ICs, and transistors. It will be stored in three different instances in different files. If manufacturing QA comes to us and has a footprint change, now do we apply that to all impacted components across the organization? There is no version control for each component. Even there is a version control system, it impractical to trace the versioning of single component within the library. Also, in such library, there is no awareness on supplier, and it's impractical to track the issues of the components across the company projects. This can be quite valuable if designers need to rapidly replace an incorrect, out of date, high failure rate components across the all project. The more advanced approach is to use database libraries. Components are printed in tabular form where each row is a component. The row contains information about the symbols and footprints and from which the library to use, as well as a set of parameters. The component is formed at the moment of insertion into the schematic from database. If it's necessary to organize a version control system, the libraries are separate. Each symbol and footprints are a separate file so you can track versions. The main disadvantage of this approach is that you need to deploy an admin to the database. For convenient addition of components to the library, users often develop custom interfaces for populating the database. It also necessary to install and configure a version control system to track the changes. There is no integration to live electronic part supply chain database, and to achieve such integration, custom code must be deployed. In short, all this custom work takes time, often comes at the expense of design time. Designers can be up and running with a freshly activated artificial workspace in less than 10 minutes. Also, designers only need to configure the component categories, and edit templates. And if we have simple footprints libraries, they're quite easy to migrate to RTM TST5. Now let us talk about the component lifecycle considerations. The lifecycle of symbols and footprints can be different from the life cycle of the component itself. For example, after a simple footprint is created, it's checked and it will upload, then no longer needed, it's moved to the obsolete. The life cycle of component may be include production stages. For example, if it is a new component, at first it will be used only in the prototypes. Promoting it to production, lifecycle state will be enabled. The component is to be used in the organization-wide design and production activities. Lifecycle stage allows you to manage the visibility of the component in the library as well as gathering the use in the project. For instance, if a component is in the draft stage, it has not to be approved or verified. Therefore, the draft component will not be visible in the design component library. Now let us discuss on the alternate designer library migrator. The library migrator has two primary modes, simple and advanced, which are listed, and the library types can be migrated. The screenshot is of simple mode, and we will cover this in the demonstration. The advanced mode enables a variety of key capabilities, including library splitting, duplicate detection, and more, as indicated in the list. This mode also allows you to combine source libraries that may have existed across a project or designer's workstations. It is a great way to consolidate any displaced libraries. As in this case, with the other domain tools, alternatives such as ActiveBomb and the Layer Stack Manager and advanced mode of library Migrator works in conjunction with the properties panel. The screenshot shows the user ability to define the destination folders, naming schemes, revision naming schemes for items related to components such as schematic symbols and the footprints. Because some of setup to map and migrate multiple libraries take some time, Migrator gives you ability to save out this configuration so that it can be rapidly restored as needed. We will show you during this demonstration. Now let us move on to the alternate demonstration about how you can, manage your libraries by using Altem Designer, Altem PHP. Now here is the Altem Designer, and here I have logged into my Altem PHP workspace. I just click on this browse symbol, will take you to the my Altem PHP in the browser. This is where you can able to access the all the content stored in the Altem PHP. If I go to the components, I to show the all the components which are available in my cloud to show. And we have got the library health dashboard. If you click on see details, to show the health of the components, what are the issues. We have some several components having issues with the part choice, stock issues, life cycle issues, outdated templates, duplicate by name. We have a list of components will be shown here. And if you go back to the components, if you click on the components capacitor, if you can see at the right side, it will show the what is the name description, and it's having some issue with the template. I have updated template recently. That's the reason it has been showing. We can fix it later. And it's the all the parameters, virtual status, symbol, footprint, data sheets, and the part choice. All we can able to see here. And next thing is about the user management. How we can manage the roles. How we can assign the roles to this manage libraries is by accessing from here. Let's go to admin. If you go to the admin, it will show the stuff related to the admin. Only the person who with the admin rights of the workspace can only able to access these settings. If we look at here, we have an option for roles. I have here a few roles: administrator, approvers, engineers, librarians, managers, and mechanical engineers. We can have a new role. You can able to define your new role on your own, and you can add many people to the same role. There is no problem. But here you can see engineers. I have assigned 3 people. You can able to see here if you want to add anyone, just enter the email ID and just enter it. And for librarian, I have added myself as a librarian. You can we can add as many multiple people to this role. Like this, you can able to add and manage the libraries. And next thing we like to showcase you about the life cycle management of the components which you are stored in the Alten 365. Let's go to life cycle definitions, and if you see, we have got the different life cycles. And now we are just discussing about the component life cycle. Just click on the component life cycle. It will show the default life cycle. This is the life cycle default one. If you want, you can have to create your own new life cycle, but here I'm just showing the default one. As we have explained during the presentation, once you create a new component first in draft mode, that means no one is verified. Once the component is verified, we'll move to the next step, prototype. And then once the component is in prototype and it is passed, and then you can move to the production level. And from prototype, if the component found it should be not available, then you move to the obsolete and then push back to the draft. This is the default life cycle. By using this life cycle, you can easily manage your component which are managed in the Altium 55 workspace with a pro subscription. Okay, this is how Altium 55 workspace looks in the browser. Now let us go back to the Altium designer. Here in Altium we have a panel called Explorer. You can see this Explorer next to cloud symbol denote this is accessing data from the cloud. This Explorer panel is like um, a user browser for browsing the Altium 365 content inside the Altium designer. See, we have got here different categories of uh, available here. When you see the under these are the component, you can see all the list of components, and we have got the under manage content. We can see the 3D models and design use templates, and I got the component templates, and if you have any Megatronic 3D models also, you can have to manage here. And we have got a layer stack of files, sheet templates, document templates. All this can be accessible. And if you look at the this components capacitors, you can able to see we got the list of components from here. You can able to see the region state. You can see this symbol is showing the region state is draft mode. Draft mode means this no one can use this symbol to manage this region state to be used or not used. You can just able to control from this thing settings, data management servers, go to properties, life cycles. You can see here the component life cycle. Here in draft mode, when it's in prototype, if you uncheck this option, allowed to be used in design, if you uncheck when the component is draft mode, the component may not be allowed to use in the uh, design. Okay, like this, we're able to control the settings once the component is in draft mode. And when you see the component here inside the this one, inside any component here, you can see the this particular component is registered as production, and you can see preview the information of the component to show the component template, what the template is belongs to, and all the footprint symbol and parameters, and this component life cycle, this how many regions it went is called the component version control. And the part choices, see the part choices added to this component. There are different suppliers having supplying the same component. We can have the multiple part choices. You can update, you can add a new part choice as well. But click on this edit, and we have option where used. This is very important. Once the component is used in the from the RTM workspace to RTM designer, where used functionality will be available, so that suppose this particular component, if you want to update, just go to this project and I can update to the latest revision. And you can see the origin from where it has been found, and the data CC where available will be shown here. Okay, this way you can able to easily browse your cloud components by this explore panel inside the RTM designer. Okay, this is all about the explore panel. Now let us jump into the next thing, how we can push your libraries or file-based libraries or outdated libraries into the RTF 55. Now let us take a close look. Now I have opened a one project which is a drone project which is available as a part of the Altium default Altium 365. If you have acquired the workspace, you can have to see this drone controller board. You can see here. This I have been pulled from the Altium 365 workspace, but I have create a library. This library, I want to push this to the alternative workspace. How we can push the library, which is a integrated library, to the alternative workspace? You can able to see the C Altim library package, which is having a similar footprint together. That is called integrated library. Even though my project is on the cloud, I don't have libraries uploaded. So how we can push this library to the identified workspace? Now let us see. See, I have an integrated library created from this project. To upload this integrated library to the cloud, just right mouse click, and we have option called import library. And if you want to upload the library which is available in your local folder or server, just go to file, library importer. This option you use, and then browse the to the file, and you can able to browse it. Okay. Now let us do it from the project, how we can push that design to the cloud. Now let us right click and say import library. When I say import library, it's going to analyze the library, what new components it is having. It will appropriately assign the appropriate component template and assign the category based on their parameters and the designators. You can see we got 140 components are part of the library, and each category having these many components, and there are mechanical, a new component category is going to be created from this library, and we have got 61 symbols and 69 footprints. And it's a simple mode. And if you want to see advanced mode, why you want to put advanced mode? We have some few and categories components we want to categorize based on that. Let us see how we can categorize. Then click on go advanced, which will open like a new window, help you to categorize the same. Now we have the library importer window. You can see on the left side what the source libraries will be shown here. And here in the middle import preview, it will show the what are the components and their categories. You can able to see the same. In capacitors, you can see a group of capacitors, and under properties, you can see the how these components are being mapped with respect to the parameters. And if you take a close look at here, each category and all are being properly assigned. And we have an issue with uncategorized components. We have 20 of this kind of components. We have 20 components are available. Now let us see how we can able to categorize this based on their functionality of the type. Now let us click on this split libraries option available. Now when I click on split libraries option, here we have a parameter option grouping. We are selected an option called map designators by component type and designator. We are selected this option because usually when you say capacitor, we use C question mark, and for other people they use CN question mark as well. If you know that particular thing, you can able to group them as per their designator. You can see register R, switch S question mark, and we have a few things to be uncategorized. We have CQ question mark. It is, Q means transistor. Let us map it as a transistor. Okay, and RJ, it is might be Ethernet jack, which we don't have that connect. That is that, we don't have a specific category. Uh, Let us skip this. Then we have U. U stands for IC. Then we add to the integrate IC circuit. And Y stands for tester oscillator. Okay, and BT stands for batteries. And FT stands for yes, let us take a fuse only. And the test point, yes, fine. This is two few which are uncategorized because we don't have a particular component category. Let us not bother about this. Let us say update. Automatically, the count of uncategorized components from 22, it became 7. We have few more, 7 more components need to be addressed. But here we don't have component category. That is not waste of time. It is exclude this from the importer. You can also do the same. But it's not a good practice, but we don't have category. I just want to show this process. That's why I just mentioned the exclude it from the thing. And now once we have done this process, the next thing is we can able to validate. Validate helps us to cross verify any issues we have with the components. It will be shown here. If you see here, we got many issues. I believe if you hover the mouse on it, it's showing the it's a warning because component duplicated. I think the same kind of component may be available, which I have uploaded earlier, which the same component might be available in this library as that's why it's showing as a duplicate. But here in this capacitors, we have some issue. Let us go to the these settings, and we can see here the problem can be seen clearly. It's been yes here. This is the one. See, it is saying same geometry. Why it is showing error? You can see based on this criteria. Invalid parameter value. It is shown as a error. That means there is some component which having a parameter value is invalid. Let us make it as a warning. And now validate. I think it is something else. Okay, it's not the related to the value. You can see there is some kind of issue, duplicate parameter first choice, and there is something issue with this one. And here we have the parameter mapping. This is also very important when you are trying to build the components based on the library parameter and template parameter. You need to map this appropriately. Okay, once this has been properly updated, and you can see the all the components here, which are going to get added. And then next thing you can do is import. Yes, if you have errors or warnings, still you want to import. Yes, I would like to import. Then it will push these libraries to the Migrating 365 workspace. This is very easy and very simple to use tool. There is no much complicated things. Just go to File, Library, in Migrator, and then you can select your integrate library and database library, and then automatically the tool will select the categories based on the component type. It will detect, and if it fails to detect any uncategorized components, like I have showed how you can map those components, we can do the same, and then just click on validate to check the are there any issues with the components or any duplicate components are available inside the this workspace can be shown here. And if you have any component which are having a issue which you need to rework, and they can upload, or you can ignore those components from updating to the other 365. Like I showed, we can have a few uncategorized components. Why I am unable to assign them is because they are not available. The category type is not available. That's the reason I ignored. But we just go back to the R365 and you can create one category and create one template and assign them appropriately. Okay, now it's been almost through, which means it's a huge library. That's why it's taking a time. I think you are almost completed. It's now operating transistor. You can see the status, what is the components being updated. See, it's been updated 121 components and it has been imported 95 models. Just click on open log or close and then go to panels and go to components. The same components will be shown here. Okay, if you guys go to all and go to capacitors to show the all the components. You can see the date. Today is 7/12. I think capacitors are into or not. Let us see diodes. Are there diodes are there? Let's see here. You can see the timestamp. This way you can able to see here. Now it is showing draft mode. And then if you want to change, if you are a librarian, you can able to operations change state, and you can able to promote this component to the prototype. Like this, you can able to push your components to the workspace. And then the same components can be seen in the Altium 365 as well. Maybe I don't have a empty workspace, but still I will show you the component which I have been added. The other component has been uploaded. Maybe you can't able to I just enable the option called R. I think this option is not available. This is how you can able to migrate your existing library to the multi-distributed workspace by using the library Migrator. This is all about the today's webinar on help ensure the best designs with component management. To summarize this, we have showed the what kind of challenges if you face if you have the file-based libraries, and we have showcased you how we can able to overcome with database libraries, and we have discussed about the challenges over there. And to overcome these challenges based in the file-based libraries and the database libraries, we have shown you the Altium 365 capabilities of migrating your libraries and creating your component categories and templates where you can maintain your parameters as per a company standard, and where you can appoint one person as a librarian so that he can manage that all those stuff. And also, we are showcasing you how we can set the roles and responsibilities, and how we can import your existing file-based libraries into the Altium 365, how we can categorize them based on their component type.